Okay.
All
So
right.
I'll explain it to you and you'll be understanding it in no time. Hopefully.
All right. Perfect. I'll copy the streaming link here.
All right. So
Also, you're not
well,
sharing your screen on the.
well, thank you for letting me know that.
Yeah.
I thought I did share it, but you're right, I'm not.
Yeah. Right.
All right, let me make sure that I'm recording it as well.
Perfect.
Yeah, it's recording. Okay. So we're talking about limits. We're talking about derivatives and limits of derivatives. So here's the formula right here. And let me just explain that to you just briefly here. I'm
Okay.
going to duplicate this and clean up this slide so that it's just this that we're looking at. All right. So we talked about limits before, right? And we know what a limit is.
Yeah.
You know, from a graphical perspective, and even know how to find algebraic limits. But now what we're talking about is derivative, which is really a key concept in calculus. Derivative is probably the key concept in all of calculus. And what a derivative is, I'll just give you a very simple example so you can understand it. If I have a graph, let's say I have a parabola that does this, okay? It would be very
Okay.
beneficial to view every single point on this parabola as a line, a tangent line, in fact. It would be very beneficial to be able to view every point on this parabola as a tangent line, because the tangent line gives a lot more information that's useful. What does every line have that a shape that a parabola doesn't have? What does every line have?
It's got exact X, Y coordinates.
Okay,
I
well,
believe.
so do parabolas, but what does a line have that a parabola doesn't have?
Does it have endpoints? Or
No,
well,
because
it's
it could be
linear, I know.
it's linear. And what makes a line a line? What's the first word that you think of when I say a line?
It's straight.
Okay, good.
Oh,
How about
it
slope?
doesn't have exponents also.
Correct. Well, it has an exponent of 1, right?
Yeah.
But that is important. What you just said is important because it's got a slope, right? And slopes are very important because slopes are rates of change, right? That line
Yeah.
has a rate of change. Does this red line that I put here, is that a positive slope or a negative slope?
Negative.
That's right. And what if I put a line over here? Is that line a positive slope or a negative slope?
Positive.
Good. And what if I put a line like up here somewhere? Does that line have a positive or a negative slope?
Positive still.
Positive, but it's smaller than the first one I drew, right?
Yeah.
Because it's flatter, right? And in fact, if I put a line perfectly right here at the top, what would you say about that slope right there if that was a horizontal line?
It's got no slope.
Well,
Well,
it has a
it has a
slope.
run, just not a rise.
That's right. So it has a slope of 0, right? It's got a
Yeah.
slope of 0, which means it's the maximum point, right? If it's
Yeah.
the point at the very top, it's not it's got a slope of 0. So can you kind of understand how viewing this parabola, this black parabola, in terms of every single point, like the slope of the tangent line, can you see how that could be a beneficial idea? Because it's
Yeah.
basically telling you a snapshot. What's happening at this point? What's happening at that point? Well, it's decreasing, right? It's decreasing at this rate right here at the slope. That's the rate that it's decreasing at, right? And what's happening down here?
Yeah.
It's decreasing at a faster rate. And how about here? It's decreasing at a faster rate, right? And how about over here? It's increasing, but at a slower rate than it was increasing here. So it's kind of like it's decelerating, right? It's decelerating or it's accelerating. So having derivatives really helps us get a lot more information about graphs, and not just parabolas, but really any graph. It helps us to think in a way, it helps us to think about the graph as if it was a line. That's what
Okay.
a derivative does. Just that's one way to think of a derivative. So having said that, what do you notice about this formula right here? What does it kind of look like to you?
Kind of looks like the f of x just with H is in there, which is the
Yeah,
limit.
and okay. And what is f of x? Is that your x or your y?
That is your X.
No,
Well, it's
f of
actually,
x,
well, it's finding your Y.
that's your y, right? So this is
Yeah.
kind of like y, think of it as like y1 minus y2 divided by, do you remember ever doing y1 minus y2?
I
How about
I
y1
don't
minus
remember. That
y2
was
over x1 minus x2?
that I do remember. That was, I
This is
think,
called your rise over your
over on run.
run, and that's what?
That's your
That's
slope.
that's what slope is. So really what this is doing,
It's kind of bringing it back to geometry, I think.
it's bringing it back to algebra 1 is what it's
Really,
doing. It's
even
the
before.
rise
Wow.
over the run. Now, sometimes you'll see it written differently. It's even more obvious because you see the x's at the bottom here. But what I'm basically doing is this. I am taking a look at, let's just take a look at this point right here. This one right here. I'll make it yellow. I'm taking a look at that point right there. There's my x value. Okay. That's
Okay.
the x. And what I'm doing is I'm finding, I'm taking like an h value. Let's see what other color I can use. Green. I'm taking um this this distance right here. Here's my h, and I'm
Okay.
taking f of x plus h. Well, actually, I should have written that on the other side. Here's my h right here. I'm taking this point right there. See how that's f of x plus h?
Yeah.
Actually, hold up. I'm saying that wrong. The point isn't h. This distance is h. I'm having a distance of h right here. I'm adding that distance h to the x, and so I'm taking that y value, and I'm subtracting this value right here, the f of x. Do you see how that's f of x?
Yeah.
This is x comma f of x, that point. So f of x is over here. And here's right here, this point is x plus h comma f of x plus h. And this point over here is f of x plus h. So what am I doing with this? I'm making h, that distance right here, this distance, I'm making that distance go to what?
0.
0, which means I'm making this smaller and smaller and smaller. I'm
Huh.
finding the slope. Imagine this slope, if I took this and this, those 2 points, and I made a line between them. But then imagine me taking this green point and making it closer and closer and closer to that yellow point, which is what this formula is doing. It's making that distance, this h distance, get smaller and smaller and smaller, which means that point is getting closer and closer and closer and closer to this yellow point, which means I'm going to get this tangent line. I'm ultimately just going to get a tangent line instead of a secant line. Instead of a line connecting 2 points, this line is going to be a tangent line that just grazes that yellow dot and doesn't touch anything else. And that's what
Okay.
I'm doing here with this formula, is finding the limit as x gets closer to 0. As h gets closer to 0, I'm finding the limit of the slope, right? This is the slope of that line. And that line is going to be a secant line, a tangent line. That's what a tangent line is. And the slope of that line is the derivative. That's what this limit is. The slope of that line is the derivative. So would that slope of this line be a positive or a negative number?
That would be a negative.
Very good. So that's going to be a negative number. And what would the slope of this line be? This blue one?
0.
0. And what would the slope of this red one be?
Negative.
This one over here to the left. That'll
Positive,
be a
sorry.
positive. Yep. And this one will be also a positive, but a bigger positive. Got it?
Yep.
So that's the idea, and that's what we're doing. And don't forget that. Come back, watch this video. after we get through all the nitty gritty, because right now we're going to get into some algebra stuff, and you're going to almost forget what it is that we're doing. So here's basically what you're going to do. You're going to calculate the derivative at these different points. X equals -1, 2, and 4. So the formula for the derivative again was the limit as h goes to 0 of f of x plus h minus f of x all over h. So we're going to plug in these values here. So I'm going to do this in red. F of x plus h means that I'm plugging in, I'll do it over here. F of x plus h means I'm going to plug in x plus h anywhere I see x, right? Does that make sense? So this equals the limit as h goes to 0 of, I'm going to do this in red so you can see, this is 4 times x plus h plus 2. Got it? Minus f of x all over h. Now let's simplify that. Okay,
So,
I'll simplify it. I'll simplify it above. This is 4x plus 4h plus 2 minus, oh, I should have plugged in f of x as well. Let me do that now. Instead of plugging f of x, I should have written out f of x. What was f of x again?
4x plus 2.
Yep, 4x plus 2. So now I'm going to distribute that negative in. So this is minus 4x minus 2, right?
Yeah.
See what I did there? Now let's simplify that. What's 4x minus 4x?
0.
They cancel out. What's 2 minus 2?
0.
They
So
cancel
you're just
out.
left with
What am I?
4h over
I'm
h.
just left with 4h on the top and what on the bottom?
H.
H. And what's the
So then the
limit?
h's cancel out, so your limit's
That's
just
right.
4.
So the limit as h goes to 0 of 4 is just 4. So your answer is just 4. Now they said calculate f prime of x. So this is f prime of x. That's what the derivative is. So basically what I just found is that f prime of x just equals 4. So does it matter what you plug in for x?
No.
There are no x's left. So the answer is always just 4. So when x equals -1, f prime of x equals 4. When x equals 2, f prime of x equals 4. When x equals 4, f prime of x equals 4. It didn't matter. It actually doesn't matter what x equals.
So it's just kind of adding a second step onto what we did last unit.
In this case, it is. And you know why it is? Let's go back and talk about what a derivative is all about. Remember what I said a derivative is all about?
It's all about
So
finding the slope at x point.
That's right. It's all about finding the slope. Well, what kind of graph is f of x?
It is a linear graph.
It's a line.
Well, line, yeah.
So the slope, what's the slope of this line?
It's positive 4 over 1. So rise
It's
of 4 and
4.
then a run of 1.
So here's your line, right?
Yeah.
And what's the slope at every single point? What's the slope at every single point of that line?
Positive.
The slope is 4. It is a line, right?
Yeah.
So can I draw like a, remember how on the parabola I was drawing tangent lines that were just grazing off of it? Can I do that? Can I really do that for this? Can I draw tangent lines?
Yeah, you could.
Not really, because it's a line. This is a line. What's the rate of change at every one of these points? The
Rise
rate
of
of
4 and
change
run of 1.
is 4, exactly. So it didn't, that already was a line, and so the derivative was just the slope, which is 4.
Okay.
Let's do another one that's not a line, and you'll see what I'm talking about. Give me another problem to do. Oh, there you go. You already have it
Yeah,
on there.
I added a few,
So,
so
all right. So f prime of x equals, so what we're going to do again, we're going to take f of x plus h minus f of x all over h. I'm sorry, the limit. We're taking the limit as as h goes to 0 of that. The limit as h goes to 0 of that. So this is f prime of x. Okay. So
okay.
we're gonna plug it in. Ready? We're gonna do the limit as h goes to 0 of, let's start plugging it in. Ready? 10 times x plus h. See how I plugged it in for x?
Yeah.
Minus 2 times x plus h squared. Okay. That's
Okay.
f of x plus h. And now I'm gonna do f of x, which will be blue, minus f of x is just 10x minus 2x squared. Got it?
Yeah.
All over h. Well, now let's simplify this up here. This becomes x squared plus 2xh plus h squared, right?
Yeah.
Times -2. Don't forget to FOIL it out. Am I okay just to do it like that? I don't have to prove that to you.
Yeah.
You good?
Yeah.
And then this right here becomes 10x plus 10h. So now let's clean that whole thing up. Let's see what we have here. It's the limit as h goes to 0
Wait,
of,
wouldn't it
I've
be
got,
negative 10x plus 10h because you got the negative and 10x is
well, yeah, I'm
positive?
not done with that. I just
Oh, okay.
simplified this one right there, just that. So
Oh,
10x
okay.
plus 10h minus, I'm going to distribute that 2 in, then -2, I'm so sorry, minus 4xh minus 2h squared minus 10x plus 2x squared all over h. Did I do that right? Check my work, please. That cancels with
Yeah,
that.
it is.
You see?
Correct. Yeah.
That cancels with that. And what am I left with?
10h
The limit,
minus 4xh minus 2h squared
10h minus
all over
4xh
h.
minus 2h squared all over h. And what could I take out of all of these things?
H.
An h. And guess what I'm going to do with that h?
Oh, you're gonna. So it's gonna be
I'm going to
10
cancel it. I'm going to
minus.
cancel it out.
Oh.
I'm going to cancel it out with the h on the bottom. So this just equals the limit as h goes to 0 of 10 minus 4x minus 2h. And what does that equal?
Would that equal
When I
just
plug
2h?
0 in, that goes away, right? And what am
Yeah.
I left with?
Oh, 10 minus 4x.
10 minus 4x. That's your derivative.
Oh.
So now this one, I can answer this question. So what's f prime of -1? So this is your
Oh.
f prime of x. What's f
It's gonna
prime of
be.
-1?
It's gonna
It's
just be
14.
5. Wait. 14?
Negative becomes a positive, so it's 14.
Oh, duh.
What's f prime of 3?
It's gonna be -2.
Good. What's f prime of 2.5?
2.5 times 4. That's gonna be the V7. No,
Won't it be 0?
here I'm right now checking. 2.5 times
2.5 times
4
4 is
is 10.
10. So 10 minus 10 is 0.
Yeah.
Okay. There you go.
Hmm.
Now, you want to see something really cool? If I
Are you
graph
gonna make a
this,
parabola
I
out of those
sure am.
points?
I sure am. If I graph this, 10 minus, there's my equation, there's my graph, right? Let's
Yeah.
factor out a 2x, and then you'd have a 5 minus x left. So what does this parabola look like? It has a
Um.
0 at 0, and it has a 0 at 5,
Yeah.
right? And the maximum is between 0 and 5, which means the maximum is at 2.5.
It's gonna look like that.
right? And what is the value at 2.5? It's
That
4,
is
5
0.
times
Wait,
2.5.
yeah, it's
It's
0.
it's gonna be up here somewhere, right?
Oh,
I don't. It
okay.
doesn't really matter where it is, but the equation's or your graph's gonna look like this. Now let's take a look at these 3 points. I'll color code them. Where's -1?
-1. It's
It's over
14.
here, right?
Yeah.
And what's that? If I draw this point on here, notice I didn't really do a super great job with this parabola. It's not like perfectly drawn to scale, but you get the
That's fine.
idea. If I
Yeah.
draw this point in here and I draw a tangent line, guess what the slope of that tangent line is?
14.
You got it. It's 14. That's the slope. And if I do the same thing for this line right here at 3, 3 is going to be, this
-2.
is 5. So 3 is going to be over here somewhere. If I draw this tangent line, guess what the slope of that line is going to be?
0.
-2. That's the slope of the yellow line. It's going to be -2. And
Okay.
finally,
Oh,
what about this one right here?
it's gonna be at 2.5. So it's gonna be right at your. Oh, that's where you get the linear line
And your
with
slope is
no
what?
slope. 0.
Not no slope. Slope of
Well, it's
0.
0. Sorry.
Yep, slope of 0.
No slope would just be a point, right?
No slope would be
Or that
like
be
a
undefined.
vertical line.
So
No
undefined.
slope, no slope is that's undefined slope. A vertical line has no slope. And
Okay.
for derivatives, to say it has no slope is to say it's not differentiable, meaning there's no derivative at that point, which is a little
Okay.
bit down the line.
So what would she be looking for then in an answer to find the derivative? Would she be looking for this whole thing?
So
Or would she
this,
be looking for just
no,
this or
no,
both?
she's not looking for this. I'm just showing you this to help you
Okay.
understand how it all goes together. She would be looking for this. There's the answer to your question, find the derivative. And then she says, calculate it for these 3 points.
Oh, so
So
she'd
we
be
just
looking for that
calculated it.
and that.
Yep.
Okay.
But I'm taking it further and I'm showing you how it looks on a picture so you can
Gotcha.
understand what it is that you're doing.
So you're just showing me the visual of what she's looking for,
Correct.
basically.
Because
Okay.
it's very easy to get caught up in all of this algebra manipulation stuff and forget really what the point is of all of this.
Gotcha.
In fact, you pretty soon you won't even do all of this mess. There's a really quick and easy shortcut to do this where I could have looked at this right away and said, oh yeah, that's just 10 minus 4x. I would have immediately been able to tell you without even doing any work. The slope or the derivative of this is 10 minus 4x. And you could
Oh.
almost see it even just by looking at it.
Yeah, you're
It's
just squaring the
10,
2.
and then take this 2 and multiply it by that 2, and then reduce this by 1. That's the power rule for
Huh.
derivatives. So it's really easy to take the derivative of a polynomial function. It's super
Yeah.
easy. It's one of the easiest things in all of calculus. But the concept itself is sometimes hard to comprehend, like what it is that we're doing. But then you can also take derivatives of all kinds of things like logs, natural logs, trig functions, all that stuff. And again, understanding the point of a derivative, or the motivation behind the derivative is to help you understand what's happening at every point on a particular function. The
Okay.
derivative helps you visualize it as a line, a snapshot of a line. In fact, that's what the slope is, the derivative is, or the slope of a tangent line is. It's the instantaneous velocity, basically. It even has applications in physics. You use the word velocity. It's the instantaneous, I shouldn't say velocity, it's the instantaneous rate of change. And you can tell
Okay.
if if it's increasing or decreasing. Is the rate of change increasing? Well, on this side, it's increasing.
And then on the other
The
side,
rate
it's
of change is increasing, but at a slower rate. It's decelerating, right? Because the slope,
Yeah.
see how that slope is getting less and less? But then when it gets to that top point, it's neither increase, that's the maximum point. So there's the velocity is 0. And then when it starts going down, now it's decreasing. The rate of change is negative, but it's getting more and more, it's accelerating as well. You know what I'm saying?
Yeah, I see what you're saying.
The rate of change is getting negative at a faster pace.
Gotcha.
I may not have said that exactly correctly, but you get the idea of what I'm saying.
Yeah, I get the
right?
idea.
Okay.
Yeah.
I don't do physics really, but I know they use this in physics a lot. So that's the motivation behind this. And you can see what she did here. Same deal, right? She's plugging those things in, canceling them out, and 4, 4, 4, 4, 4.
Oh, I
Right?
even see the
And
shortcut on the first one.
yep,
How
the short, yep.
basically the
That's
two cancels out.
Yeah, well, this is just a constant, so you don't even use that.
Yeah. So you're just using the
The
four.
shortcut, your
Wow.
teacher is going to hate me for teaching it to, but the shortcut is you take, like, I'll just do a simple one. Y equals 4x squared minus 3x plus 2. You take this,
Is it gonna be
you take
16?
the exponent and you multiply it,
So
and
it's
then
gonna
you
be
reduce it by
16x
1.
minus 3.
Not 16. You multiply it. Don't square it. You
Oh, so it's
multiply
gonna
it.
be
It's
8x minus 16.
8x
Minus 3.
minus
Ooh.
3. That's right. Because this, you take that, you multiply it, so it's 3, and then you reduce it by 1. So this, you just wouldn't write that at all, because that's got the exponent of your x is 0. So 0 times 2 is 0. So it's just gone. So the derivative is 8x minus 3. So it's very easy to do. There's really no secret with that. Whoops.
Yeah.
There's no secret with that, but that'll help you understand.